So here's our outline for today. We're going to start with just a really quick introduction of why we think this tool is useful. And then Katie will be giving kind of the bulk of the presentation, explaining how she went about doing this updated modeling for New Hampshire, both the methods as well as the results. We'll take some time for questions. Hopefully we'll have about 15 minutes or so for questions and discussion. And then Corey will end with just a couple examples of next steps and how we're trying to use this modeling tool. So these are the voices that you'll be hearing from today. Corey Riley, as I mentioned, she's our manager and fearless leader of the reserve, and she's really been a champion for all things salt marsh. And so she'll share a little bit about how this SLAMM tool can be used to really help us kind of think hard about the way we protect salt marshes. Katie Callahan, as I said, will be doing the bulk of the presentation. She joined Fish and Game in 2003 to head up their Geographic Information Systems program. And prior to that, she was with the Department of Environmental Services, and she's a master's in environmental science and policy. So really great background for what she's sharing today. And you already heard a little bit from Chris Peter, who's our research coordinator at the Reserve, and you may hear the voice of Rachel Stevens as well. She's our stewardship coordinator and wildlife ecologist and also a GIS specialist. And she's actually sick. So you may or may not actually hear from her today, but she was really instrumental in kind of helping steer this process and working side by side with Katie.
So what I'm going to say is not a surprise to anybody on this call. When we talk about why we wanted to model what the impacts of sea level rise on salt marshes will be, we come at it from a couple of different perspectives. And one is just recognizing all of the amazing ecosystem services that salt marshes provide to people. They serve as habitat for fish and wildlife. They are important flood storage areas, carbon sequestration areas. They filter our water. And we believe at the National Estuarine Research Reserve that it is a part of our mission to protect and steward estuarine habitats, and in particular, those who are threatened. Salt marshes have been threatened throughout time by the way that we have interacted with them. We've ditched them and bermed them and built railroads through them. And that is really compounded by the threat of sea level rise. So this particular model is looking at how sea level rises will impact this really important habitat. We also are thinking about this from our fish and game perspective, where salt marshes were ranked one of the most threatened habitats in our recent wildlife action plan. And that wildlife action plan really kind of shapes a lot of the work that we do as an agency. And so we need to understand where marshes might move and how they might change so that we can also think about how we're going to manage the fish and wildlife and the vegetation that they depend on in the future. Next slide, please. And when we talk about and when you see the results of the model, we really just want to stress that this was a great opportunity to update and expand upon science that's been happening for several years through our work and through the work of partners to understand what impacts climate change will have on the resources that we are managing. We are really lucky in that we have new tools, we have new data, and we have amazing people like Katie and Rachel who know how to put those to work in order to help us predict what these changes will be. And if we have some sense of where these habitats might be in the future, we can be proactive. We don't have to wait and watch as they change and maybe go away. We can be proactive in creating new habitat and protecting migration pathways and in working together on land use management scenarios that can help enable our species to move and our habitats to move in the future. And that's really kind of why we're in this, and what we hope to be able to achieve is some common understanding of what we might see in the future and what we might be able to do about it. So Katie will get into more detail, but we were especially lucky to have a new LiDAR data, so elevation data, and very high resolution spatial data sets for our wetland habitats. These two data sets combined really give us a uniquely powerful analysis when it comes to SLAMM. This model has been used around the country by a lot of different places, but we feel like we have particularly great data. And in New Hampshire, we have a small enough state that we can analyze the entire state's salt marshes using consistently high quality data. So we're really excited about the opportunity to update this model and to explain it to you today. And with that, I'd like to hand it over to Katie.
Thanks, Corey. So the gist of my presentation is to go through basically the tools that come with the software itself. And as Lynn introduced, I'll go with the acronym for now. And so when I'm referring to SLAMM, it's the Sea Level Affecting Marshes Model software. As with any GIS project that I've been involved with, it's not just, the GIS specialist running the tool. It takes a whole team of individuals to look through, what parameters to use, the best data sources. And so this was certainly a team effort, just like all projects are. UNH and Fish and Game, Department of Environmental Services, Granite at UNH, and a couple of private conservation contractors. And so what is SLAMM itself? And it's a fairly robust tool, but a nice, easy interface. And it was originally developed in 1986 with some EPA funding, but it has had several iterations and improvements since then with funding from other national partners. It's free, open source software. It does require some desktop GIS software to prepare the input sources, but otherwise SLAMM itself runs completely independently. And so just to go over the model process, it basically is simulating the processes that are involved in the conversion of wetlands under different scenarios of sea level rise. And so we first ran SLAMM in 2014, and we decided to rerun it in this just a couple months ago in December, as Corey mentioned, when we had new data available to us. And I'll go into those sources in a little bit. The way that it works is it actually takes the current existing elevation and lowers it. And so that's how it simulates the impact on wetlands from sea level rise. And so it's adjusting like the salt boundary, the tidal range, and the elevation of each cell changes. It looks at other things like erosion based on the maximum fetch, accretion, and it looks at accretion because of course the sea level rise can be offset by sedimentation or vertical accretion. It looks at soil saturation, and it also changes in the freshwater water table due to sea level rise. And so the way it works is the first step is to convert the LiDAR data. It has to correct it to a vertical datum at mean tide level. And it does that using a factor that comes from NOAA's VDatum software. And it's important to recognize that this conversion to mean tide level differs between sites. And so for New Hampshire, we split the areas up into regional sections based on those differences. And and you're going to hear me repeat this today, but just so everyone's aware, any prediction from the model is always affected by uncertainties. And so the results, when you see them, it's not any one single result that's the best result. It's more like there's a distribution of possible future wetland habitats. So one of the first things required in SLAMM is that your baseline data, the wetlands data, has to be crosswalked with very specific categories used in SLAMM. And what you see on the screen now are the habitats that the software uses. The interface itself, as I said, is pretty straightforward, and it comes with a very good user manual and technical notes that goes into great detail explaining what each of the tools do within the program. And we start with the file setup button, and the file setup is where you enter the links to the required data. And those requirements are elevation data. So we used a digital elevation file based on LiDAR. The SLAMM categories, as I mentioned, any wetlands data has to be converted to the codes that the SLAMM software uses, and a slope file, and that is derived from the DEM. There are some other optional files that can be input, and we did not use that in this run. And I just wanted to draw your attention, for anyone thinking of using SLAMM or thinking of rerunning it with high resolution data, draw your attention to the bottom of this file setup, where you have an option to let the software track all the cells in your study area or exclude those that are high elevation and open water. And, as you can see, even one of the smallest areas, required 11 gigabytes in memory utilization. So and that was for the Portsmouth Harbor area, one of the smaller of the regional sites. So by checking the option to do not track high elevations in open water, it considers high elevation that's anything that's 8 meters above mean tide level. I did just, if the question comes up, I did try running SLAMM and tracking all cells, and even with a very new, well-powered laptop, I had out memory errors and had to quit the program. So the next input are the site parameters, and as you can see in the towards the right side of the slide here, these are the subsites that we used for New Hampshire, and that's because the input values will differ between those sites. And those input parameters include things like, well, for the entire, for all of New Hampshire, the photo date, which was 2013, that's what the high-res wetlands are based on. The new LiDAR data was actually flown in 2019, but we just received it a few months ago. And some of the first sets of parameters will be the same between sites, but some of the others will differ, and I'll go through those in a moment. There is one new part of SLAMM that we did not use, but for those that might be interested, it is available with the newest version of the software. And that's, you can actually vary the accretion rates between sites. But for New Hampshire, we used a constant accretion rate. So once you've identified the required data inputs and the site parameters, then you decide which sea level rise scenarios you're going to run the model for. It's very flexible this way. You can run it for any custom sea level rise. It's all the data, input data has to be in meters, just so you know, and the model can be run at regular time step intervals or just for specific years. And so for this rerun in New Hampshire, we chose just 2 years, 2050 and 2100. Just to go back 1 second, we also ran this and did not protect developed land. So for those of you viewing the results, you'll see this later. Yes, developed land cover can convert to potential future wetlands. And we, as mentioned, we had some updates to the local input parameters. One of those updates was for the, sorry about that phone. For new data for the Great Diurnal Tide Range. And that source came from one, a new data for the Great Bay Estuary. And that was the Great Bay Tide Gauge, which was recording from 2017 to 2019. And I'll just add here, this is important to get current data because when we ran the sensitivity analysis back in 2014, tidal range was a very influential parameter in this model. So we wanted to use the most current information available. Another set of new tide gauge data was for Hampton, which was collected 2013 to 2020. And the last one was for Squamscott River that had a tide, and that was collected from July to September of 2022. And as mentioned at the beginning, we also now have some very high resolution tidal wetlands data, and that is served as our baseline, and not only the baseline for SLAMM, but we're also going to be looking at habitat change. And I think that will be discussed a little bit later in this presentation. But this high-res tidal wetlands, they were derived from 1-foot imagery, which was acquired by the Piscataqua Region Estuaries Partnership, along with LIDAR for the Northeast. And there were several iterative improvements and field verification by staff at the Nature Conservancy, the New Hampshire Coastal Program, UNH, and Great Bay Reserve staff, where they went out and verified the information for 327 different field locations. And so with that iterative improvement, the final data product has a 92% overall accuracy, which is really good for any land cover product. So in 2014, what we had available to us was the National Wetlands Inventory wetlands. And with this new rerun in 2022, we had the high resolution tidal wetlands. And you can see, I mean, even just ignoring the classes and colors here, you know, you can see the difference in just the level of classification achieved in this newer product. So as I said, even with this new high-res wetlands data, we still have to do a crosswalk so that we can put that information into and assign the SLAMM codes required by the software. The neat thing, though, is it still retains the delineation of that higher resolution data. The LiDAR data, which just got flown recently for coastal New Hampshire and also for the Nashua area, was collected in fall of 2019 and spring of 2020. For this particular location in the coastal area, it was the fall of 2019 data covered it. The resolution is just over 1 foot cell size, so very high resolution elevation data with 10 centimeter vertical accuracy. Previously, we were using a 2-meter resolution LiDAR data. There are a couple other data sources that we got our hands on, and one was some additional mapping of salt marsh ditches by Fish and Game staff, Great Bay staff, and the new impervious surfaces, which was a project with Granite and the Piscataqua Region Estuaries Partnership. So the last input needed were decisions on the sea level rise scenarios to use. So what was chosen were 2 different scenarios. One was a short term, which was used for more of a restoration focus, and the long term would be used for looking at marsh migration and land protection. This is based on new guidance for sea level rise that was released by Department of Environmental Services. And so they had a range of potential values that could be considered. The short-term scenarios, there are 2. One is very likely to occur, one is somewhat likely to occur. And for the long term, these sea level rise estimates are less conservative. And so they can show the possible extent of marsh migration. As I mentioned, there's a lot of uncertainty in the results. So it's good to look at all of these together, not focus on any one in particular. And so once each of the subsites was run through the software, they were all merged together into a single statewide data set. And that is available on the New Hampshire Coastal Viewer, which is hosted on Granite by UNH. And if you're not familiar with the Coastal Viewer, once you start it up, the new predicted marsh migration will be found under the Oceans and Coasts group. And you should see links to the SLAMM 2022 results with both the initial conditions and then each of the 5 different scenarios. I would add here that for the viewer, anyhow, the classes have been grouped into like a simplified display. And so it allows you to compare the results from initial conditions in each of the sea level rise scenarios. So within the viewer, it's this simple classification. However, if you do happen to have GIS desktop software, you can download the data in a polygon format. And those polygons will give you the detailed information of both what the initial condition category was, what the future condition will be, some attributes that I added just to make it simple that, is the status of that particular salt marsh polygon, is it going to be lost or persistent, or is it potential future marsh? That's all available in the data download. And so this is just zoomed in to an area so you can compare the results from our 2014 analysis on the left to the new 2022 analysis on the right. I think probably, the footprint is just more refined. It will seem very similar. There weren't any really large or significant changes. I think I mean, as far as the overall extent. The biggest change was, I think the newer data does a better job at reflecting the uncertainty in the inputs. And so you will see, as you can tell here, larger areas that are considered transitional salt marsh. And that in this category is shown in red. And so just to go over a few different statistics for the results, this is by region. And not surprisingly, some of the largest extents that will be either persistent or potential future salt marsh are in the Hampton Seabrook area. Some of the highest potential based on percent area is at the Squamscott River. And the highest amount lost by percent is Cocheco River. We can also look at these results by town and using the same kind of statistics, we can look at by area or by acres, the greatest potential and persistent area is in Hampton and Rye. The largest area lost is in Seabrook. And yet, if you look by percent, Seabrook also has some of the most persistent salt marsh looking ahead into the future. Madbury, which usually kind of gets dropped off because there is a little bit of salt marsh in town, but if you look at the percent change, Madbury has the highest percent of potential future marsh, but it's just at 20 acres. Similarly with Rollinsford, it has the highest percent lost, but that's just at 7 acres. So anyhow, all of this information, whether you wanted to look by region or by town, this will all be available along with the results. And so, as I mentioned before, I will repeat myself here with just a reminder that results of any spatial model are always affected by uncertainties, and therefore there's no single prediction that's the correct one, but rather there's a distribution of possible future habitat changes. Thank you.
Yeah, thank you, Katie. That was really comprehensive and thoughtful and just nice. I learned a bunch. So we're going to pause now and see if there are questions about both methods or results. And then, as I said, we'll kind of end with some comments about next steps and applications that we see as a reserve. And as a reminder, I encourage you all to type your questions into chat, or you can raise your Zoom hand, and Corey and I will try to keep an eye on folks who've got questions. And we're going to keep the slides shared, but you can kind of slide over and kind of reduce the size of the slides if you want to be able to see some more faces during the Q&A time. So I'd like to start actually with a question that Dwayne sent to me directly. And Corey, I think this actually might relate best to you. But Dwayne was asking for some specific guidance on how you see these SLAMM results being useful in the land protection context. And specifically, he caught Katie's comment about using that highest sea level rise projection specifically for land protection situations.
Yeah, thanks for the question, Dwayne. And I know that we'll be digging into this together through the partnership. But when we talked about which scenarios to use, which sea level rise scenarios to use, the takeaway for land protection is if we were looking at, if what we were looking for is to protect potential migration pathways through land protection, then we want to look at what the greatest extent of that marsh habitat might be in the future. So using those higher scenarios, also just recognizing that land protection hopefully is sort of a forever activity. So it has the longest time frame as a management action as well. So, the recommendation that I would make is that when SELT or any other partner who's involved in land protection takes a look at these results, you use that higher scenario at the 2100 year. So again, there were 5 scenarios. There are 2 for 2050 and 3 for 2100. And so I would encourage SALT and other land protection partners to look at the 2100 higher scenario. Hopefully that answers your questions, but feel free to follow up if you wanted something else.
I see a thumbs up there from Dwayne. Thanks, Corey.
There are some more questions in the chat. Lynn, do you want me to start digging into those?
Sure, go for it.
Okay, so the first one is from Pete Slavinsky, and he asks, comparing the original 2014 data runs with the newer SLAMM model runs, was it less or more time intensive? That's a question for you, Katie. And are there any areas where the results were dramatically different than the original data runs?
So the newer version took about a month to run. And I think there has been great improvements in the SLAMM software. It's now a 64-bit process, which helps considerably. But the data being such high resolution data still took a long time to get to run each subsite. As far as dramatically different results, not that I've found. We did have some issues where I think the cause was something within the LiDAR-based digital elevation model where there is some very artificial horizontal banding occurring in some of the results. It's not an issue when the habitat classes are grouped together and you're looking at just salt marsh potential or future. But if you do look at the more detailed classification, you will see some horizontal banding in the results, unfortunately.
Okay. Thank you, Katie. The next question is, does the model take the 19-year metonic cycle into account?
Not that I'm aware of, no. I assume that would impact the tidal range.
Yeah. Okay.
I can jump in real quick on that.
Sure.
I think it's baked into the actual predictions of the certainty levels that we input into the model through the NOAA water level. So it's already baked into there. So whatever time period we're looking into would already be into what would be the prediction of the metonic cycle. So we just came off of a little bit of a lull. We're entering more into a peak. So it depends on what your time endpoint is and where that takes place for the metonic cycle. So I would say, I'm not an expert on this, that it is already built into the NOAA tide predictions.
Thank you, Chris. And Dave Burdick agrees with Chris, which is always nice to hear when our salt marsh people agree with each other. The next question that I see here is, does the model include any of the dams along the tributary rivers?
It includes dams in that they are represented in the higher elevation LiDAR elevation data.
Okay.
So, I mean, once sea level rise reaches a point where that dam is overtopped, then anything upstream of the dam is allowed to convert if it meets the other criteria in the model.
Great. Next question is, I may have missed this, but where did you source the tidal datums for each subsite?
So the LiDAR data is NavD88 and it needs a correction factor applied, and that comes from NOAA's VDatum software. And what I did was I just took an average, but unfortunately the VDatum coverage doesn't cover the entire area. So I just took an average for each subsite.
Okay. There's another question here about, does the model predict net increase or decrease in the marshes? So assuming that sea level rise will create new marshes as well as flood existing marshes. So maybe Katie, can you just go quickly to a slide where it shows the lost gain persists and walk through that a little bit?
Yeah, maybe Lynn can back up a slide or two. It is, it's not in the coastal viewer, but it is available in the data that can be downloaded. And so the attribute field's called salt marsh status. So if the model sees it as salt marsh at initial conditions and salt marsh in the future, it's considered persistent. And constantly, same for if it exists in the initial conditions but not in the future, it's lost. And then if it's dry land or some other freshwater wetland type initially but converts to salt, then it's a potential salt marsh.
Great. Hopefully that answers Paul's question. We have a follow-up on the dam question, which is, could this be rerun for a dam removal? For example, the
Yes.
Mill Pond Dam
Yes,
in Durham.
definitely. Yep,
Great.
and I think we had some discussions about that just with any tidal crossings as well.
Can you provide a definition of transitional salt marsh? So those red areas.
Yep, it's I don't have the official definition, but it's areas that are that are having saltwater intrusions that are converting to a tidal wetland habitat type.
So just for kind of illustrative purposes, you might see places that are starting to have changes in vegetation, and those would be transitional salt marsh areas.
Yeah.
So the next question is, what was the constant accretion rate that you used, and what did you base that on, the accretion rates?
I may have to defer that to one of you. I was
I think
given
I know the answer to
accretion
that.
rates, but they are
Yeah.
constant. We didn't
Okay.
vary them, but
Yeah, I think we used set tables that we have deployed around the estuary to look into that. And we also looked at some set tables in the region. I know the last time that we did that. Now I'm going to open it up to Dave Burdick or Chris Peter to deny that if that's not true.
I guess I'll take a quick stab and then Dave can counteract me if he or confirm. Yeah, so surface elevation tables, we track marsh elevations in terms of millimeters to help us understand accretion rates in marshes. We have them around several marshes in New Hampshire, thanks to Dave in Hampton Seabrook and Great Bay. So I assume that we're using those accretion rates from our instrumentation out in the field to inform those areas. We don't have all the areas. So we might have used like closest geographic area for places that we don't have SETs. So that's my guess.
Yep. And as I understand it, we also looked at, how long we had accretion data for, because we wanted to capture accretion rates that not sort of short-term accretion rates, but things that had been around for a while. The next question, I'm interested in the difference between predicted versus actual tides, and if you've been able to calculate an error or uncertainty on that. In the last few years, tide levels have frequently exceeded predictions.
as far as what was used in the SLAMM model, it's an average. So there is part of SLAMM that can account for storm surge. We did not use that, or that option was not used. We just used an average.
Okay. For Rachel, who asked that question, Rachel Stearns, if you have a follow-up, let us know.
Can I add really quickly to that?
Sure.
So I guess maybe I'm misinterpreting the question too. So we're looking at predictions. Some sites will be predictions based off like historic tide stations, and some sites are based off of like actual observations, and so like ongoing tide stations. So we'll be using the actual data when we have it, and more predictions when we don't. And I think hopefully I'm adding more clarity instead of confusion. And I know we have really some good expertise on tide level monitoring here too. If anyone else wants to jump off too, that would be great.
Okay. Our next question is from one of our tide experts, Jamie Carter. He asked, were there any adjustments made to the LiDAR-derived marsh surface and adjacent upland elevations to correct for potential bias?
No, I did not make any adjustments.
Okay.
That said, Jamie. I would welcome any suggestions.
Okay, great. So that might be an ongoing conversation, which is exciting. Always want to make it better when we can. And Kyle is asking, what is the connection, if any, between using this model with results from ongoing groundwater rise modeling studies in the coast? Can these two data sets be used together to help make land use decisions, or do you feel that they should remain separate? I can opine on that if you want, and then I'll open it up to anybody else on the call who might want to opine on that as well. I think it would be really interesting to look at these two together because the groundwater rise modeling, I expect will show us where some freshwater wetlands are going to show up in the future. And a lot of times in the SLAMM model, you know, the first place that a tidal wetland goes is into a place that's already a freshwater wetland. So I think it's, you know, it's going to be interesting to see how the overall footprint of wetlands in coastal New Hampshire might change in the future. And there are all sorts of implications for land use planning, including sort of regulatory implications for that in the future. Hopefully that's more of like a conversation starter, Kyle, but hopefully it gets at what you were asking about. Dave Burdick in the chat, people can read it, just kind of gave a clarification for set data. And the next question is, could you speak to the presence or consideration of land subsidence in the SLAMM model in this area, or how to factor it in if applicable?
So it is included in the model based on erosion. I guess I don't have a lot of detailed answer beyond that, other than the model can accommodate you know, transition from marsh to mudflat based on erosion in the future.
Okay, and the next question is, there was a big increase in open water in the 2022 map versus the 2014 map, which had extensive mudflat on one of your slides. What can you attribute that change to?
Yeah, that's just showing it. I wouldn't treat that as being different. Yeah, it's more just a display issue. Those areas are still going to have areas of extensive mudflat at low tide. It just means that the habitat class is going to be an open water mudflat class. It doesn't necessarily reflect a change in the habitat type.
Okay. And again, Dave Burdick provided another little clarifying point about the groundwater. So please go into the chat if you'd like more. Okay. Those are the questions that I see in the chat. Do we have anybody who has their hand up? Okay. Anybody else want to add anything to the discussion or clarify any points that we've got a lot of experts on the call, so I welcome any of you to jump in. All right. Well, hopefully, again, this presentation is a start of a dialogue with a lot of you, because we don't want to just run the model, we want to use it. And so that's kind of how we'll talk about a few next steps in the next couple of minutes. So the first thing that I want to talk about is how we are working on multiple predictive tools, and this is just one of them. So Lynn, can you advance it to the next slide, please? So we have been working for several years really closely with the New Hampshire Coastal Program, with UNH, and with a very large group of partners on a geospatial-based salt marsh plan for New Hampshire, which really kind of breaks our salt marshes up into individual units and analyzes each of them for their resiliency based on current condition, vulnerability to sea level rise, and adaptation potential. So this is interesting because the SLAMM outputs are an input to this tool, this geospatial tool, but they can also be used like looking at them together to help shape management actions. So we're giving you a teaser on this because it's going to be available in a geospatial viewer. There's going to be a lot of products kind of baked into it, but all of them are with the end hope that this can be a planning level tool to help inform sort of strategic decisions about where to invest in restoration, land protection, and where you might think about other land use decisions related to salt marshes. Once this is over, we're going to be asking to see who's interested in hearing more about some of our next steps. And this is one of the ones that we wanted to pique your interest in. As we mentioned when I was giving my introductory comments, we're really interested in these predictive tools. And we're also interested in verifying them and making them better each time we run them. So next slide, please, Lynn. This is an example of how we think we can use these different predictive tools together. The purple shade that you can see is showing the extent of the potential marsh in the latest SLAMM run using one of the higher scenarios. And then the different colors that you see are some of the recommendations for management that are coming out of this predictive tool, the Salt Marsh Plan that we are working on now. And so what this can show you is that in some places where marshes are likely to be in the future, we also can see what types of restoration efforts now might help enable that marsh migration. So for example, around the mouth of the Swampscott, which is one of the places where we might gain the most salt marsh, we also see that we have salt marshes in that light blue color that may need some help to reduce their vulnerability to sea level rise. That's just one example, okay? We also have some bright green spots that pop out on this map. And those bright green spots are places where we think that there's a lot of potential for conservation efforts that could help conserve and protect our salt marshes. So you can look in sort of that rye area and you can see the purple SLAMM modeling where we hope to gain some salt marsh in the future. And you can also look at where there are some real conservation opportunities. So that's just an example of how we can use two predictive tools together, or how we're hoping to in the future. We are also hoping to have like a little bit more effort within our team and with our partners to sort of provide technical assistance for people who want to figure out how to use these type of predictive models at your community level or organizational level, and to work across our partners to help us sort of get on the same page as far as how to approach some of our investments. Next slide, please. So as we do these things, it's going to be really important for us to make sure that we are linking these modeling efforts to what's really out there in the field. So our reserve, in partnership with so many partners, has also been really involved in watching on the ground how salt marshes have been changing over time to put these models in the context of what we're seeing out on the ground. And we also have been doing a lot of work to sort of field verify both the habitat maps that have been created, and now we're developing protocols to field verify some of the SLAMM results. We also always encourage that these geospatial tools are used as sort of a screening, a first step, and then you're going to want to get out there and get muddy to see what's really happening in the area and to collect data, especially if you're going to take a management action like restoration. Next slide, please. Another project that people on this call might be interested in is, we talked about the fact that the aerial imagery that was used to create the high resolution tidal wetland data, habitat data, was flown in 2013. And we are working with partners. Huge shout out to the Coastal Program at PrEP and NOAA for helping with this, to fly imagery again in 2023. And then we'll be working to do a change analysis to see how these two imagery products compare over a 10-year time frame. That's really going to be one of the first times that we can see how these tidal habitats are shifting, and we think that's going to be really valuable to the whole community. And next slide. So now I'm going to turn it back over to Lynn, and she can tell you about how you can learn more about all of these exciting things that we are up to. And then maybe we'll take a couple final questions if we have time at the very end.
Okay. Yeah, we're just about top of the hour, but I'll just say briefly that at the end of this webinar, you'll be getting an email message from me that'll include a quick survey just to get some feedback on this webinar. And also in that message will be an invitation to join a mailing list for announcements for future events like this webinar. And we anticipate this being, a handful of messages over the course of a year. But we do have some of these, products that we're really excited to share with folks. And so we invite you to kind of be part of that and to receive the most up-to-date information from the reserve and from our close partners. So a little plug for that, both the survey and then joining the mailing list. And I do want to make sure we end with a big thank you. And I think I see that there's been a couple comments in chat, some back and forth about some maybe ways to kind of improve the way we explain the SLAMM results, which is really helpful. But I don't think we have time to take any more questions. So I'd like to just end with a really big thank you to everybody who participated today, and especially to Corey and Katie for a really thoughtful presentation. And to everybody for kind of showing up and bringing your brains. And many of you contributed to this work along the way. I want to just acknowledge that. So thank you to those who've contributed and who will hopefully take some of these results and these tools and use them in your work. And be in touch, because we're really interested in continuing to partner in the use and the improvement of these tools for our salt marshes. Anything else, Corey, to say as we wrap up?
Nope. Thanks for showing up, everybody. And please do get in touch if you want to know more or if you want to work together to put this to use. So thanks again, everyone. Have a great day.